Now we are going through important properties or important formulas of matrices and determinants. See, note these down. It's very important. Determinant at j is equal to determinant A raised to n minus 1. Determinant A power n minus 1. See here, what is n? N is the order of the matrix A. See, very important, all these properties. After understanding the concept of all the chapter, see, you should go through these properties. So you should write all these properties together and study. Okay. So here, next is determinant A is equal to determinant A transpose. Okay, after going through this, let's go to some examples based on this. Okay. Determinant A is equal to determinant A transpose. That is, when you interchange rows and columns, the determinant value is same. Remember, see, let's take one example. 2, 3, 1, 5, matrix A. Take its determinant. What is its transpose? Transpose is nothing but 2, 1, 3, 5. Okay. Its determinant 2, 3, 1, 5. Here 2, 1, 3, 5. Okay. See, it is the transpose, right? Okay. So what is the value? 10 minus 3, that is 10 minus 3, 7. Here also 10 minus 3, 7. So when you interchange the rows and columns, the determinant value is same. So remember, determinant A, that is equal to determinant A transpose. Okay, so very important. So all these properties are very important. You should be aware of all these properties. Okay, next is determinant A inverse, that is equal to 1 divided by determinant A. See, based on this, we have already done a problem, right? So, determinant A inverse, that is equal to 1 divided by determinant A. Remember, if A is singular matrix, then at J is also singular. If A is singular means determinant A is equal to 0. If determinant A is equal to 0, then determinant at J is also 0. So keep it in your mind. If A is singular, then at J is also singular. That is, if determinant A is equal to, if A is singular means determinant value is 0, right? That is, determinant A is equal to 0, then determinant at J is also 0. Next is adj A transpose. That is, adjoint of A transpose. That is equal to transpose of adjoint A. See, not only writing, see, you should understand the concept, okay? Adj A transpose is equal to adj A whole transpose. That means, see, suppose it is given, adjoint of a matrix is given. Okay, you are asked to write the adjoint of A transpose. Okay, matrix A is given and its adjoint is also given. Okay, you are asked to write the adjoint of A transpose. So how will you find? See, you know how to find the adjoint of the matrix. Okay, but see, if you know this property, on the spot you can write the answer, right? The adjoint of A transpose, that is equal to adj A transpose. Means when you take its transpose, you will get the answer, right? So here, adjoint of A transpose. See, it is given, adjoint of A. Okay, adjoint of A is given. You are asked to write the adjoint of A transpose. So, adjoint of A transpose is transpose of adj A. Okay, so you just interchanging the rows and columns. That's the answer. Okay, so next, here determinant Ka is equal to K raised to n into determinant A. What is n here? N is the order of the matrix A. Okay, see, based on this property also we have done a problem. Okay, so determinant Ka is equal to K raised to n into determinant A. Suppose matrix A is of order 3 by 3. Then here determinant Ka is equal to K cube. Okay, K cube into determinant A. Next is A inverse transpose, that is equal to A transpose inverse. Okay, similar to this one. Okay, See here also, this matrix is given. That is, inverse of a matrix is given. Okay, inverse of a matrix is given. Matrix A and its inverse is given. And you are asked to write the inverse of A transpose. Okay, transpose of a given matrix. So how will you find? You know what is the process, what is the method to find the inverse, right? But you know it takes much time. So, and you don't have enough time in your exam hall also, right? So, if you know this property on the spot, you can write the answer, right? See, A inverse is given, okay? So, matrix A and its inverse, A inverse is given. You are asked to write the inverse of A transpose. Inverse of A transpose. That is, inverse of A transpose. Inverse of A transpose is the transpose of A inverse. Here A inverse is given, right? Okay, A inverse is given. So you just take the transpose. Find the transpose. That's enough. That is the answer. Okay. So here, 8th one. Determinant A raised to n, that is equal to determinant A raised to n. Okay, determinant A raised to n is equal to determinant A whole raised to n. So everyone, so okay, now let us go through some examples based on these properties. So before that, see, I am saying that everyone please should go through these properties, okay, and study. Look at this example. Value of a 3 by 3 determinant is 3. Okay. Value of determinant formed by its cofactor is dash. See here, we know that determinant at GA is equal to determinant A raised to n minus 1. Right? Here, it is given. Determinant of a given matrix, 3 by 3 matrix is 3. Okay? Determinant of a 3 by 3 matrix is 3. Here, we have to find, okay, what is the determinant of cofactor? See, what is a cofactor? What is the relationship between cofactor and adjoint? See, here we know that adjoint is nothing but transpose of a cofactor, right? So, here we can write adj is equal to determinant of adj is equal to determinant of cofactor matrix, right? Why? We know that, see, it is nothing but, adjoint is nothing but transpose of cofactor, right? And here we know that determinant A is equal to determinant A transpose, right? That is, when you change in, interchange in the rows and columns, the determinant value is 0. Sorry, determinant value is same, right? So here determinant value is same. That is, determinant at J is equal to determinant cofactor. So here it needs to find, so what is determinant of at J? Here determinant of at J is equal to determinant A raised to n minus 1. Right? See, if we know this property, we can write the answer. Okay? See here, determinant of at J is equal to determinant A raised to n minus 1. What is determinant at J? See, it is given. Determinant of A is given. That is 3. So, 3 raised to, here what is n? N is the order of a matrix A, right? That is, what is the order here? 3. So, 3 raised to 3 minus 1, that is 3 square, that is 9. So, we have got determinant at J is equal to 9. And we need determinant value of cofactor, right? That is, determinant of cofactor is nothing but determinant of at J. Okay? So, the value, answer is 9. Understood? See? It is the property we applied here. Okay? Determinant of at J is equal to determinant A raised to n minus 1. And you should know determinant of at J is equal to determinant of cofactor. Right? Because determinant A is equal to determinant A transpose. Okay? That is, when you interchange the rows and columns, determinant value is same. See the second example. If A is equal to matrix P to 2P and determinant A cube is equal to 125, then find the value of P. Here, If determinant A is given, it's very easy to find the value of P, right? But here it is given that determinant A cube is equal to 125. Okay, suppose you are not aware of any property, how will you find the value of P? See, you will find A cube. How? Matrix A into matrix A into matrix A, right? That is matrix A cube. So here after that you will find its determinant, right? See, it will be very long and you will get a polynomial of degree 3 or 4. Okay, after that you have to factorize it. It requires much time and you will lose your confidence. Okay, so please everyone, please go through the properties. See, not only in determinants, all the chapters, after learning all the chapters, you go through, you study all the properties whatever you learned. Okay, write all the properties together and study with it. Okay, practice with it. So here what is our property? Determinant A raised to n is equal to determinant A raised to n. Right? Determinant A raised to n is equal to determinant A whole raised to n. So here it is given determinant A cube is equal to 125. Okay. So we can write it as determinant A whole cube, that is equal to 125. Okay. Now determinant A whole cube is equal to 125 means what is the value of determinant A? This implies determinant A is equal to 5. 5 cube is 125, right? So determinant A is equal to 5. Now we have determinant A. Now it is easy. We can find the value of P very easily, right? That is determinant A is equal to determinant P to P, that is equal to P square minus 4, right? So determinant A is equal to 5, that implies P square minus 4 is equal to 5. Okay? So P square is equal to 5 plus 4, that is 9. So what is the value of P? P is equal to plus or minus 3. Okay? So P values are plus or minus 3. Look at third example. If A is equal to matrix 1, 2, 3, minus 1, 1, 5, 0, 3, 4 and at J is equal to matrix minus 11, 1, 7, 4, 4, minus 8, minus 3, 3. Then what is at A transpose? Okay. So here we need to find at J A transpose. At J is given. So our property is, formula is at J A transpose is equal to at J A transpose. That is transpose of at J. Here we need to find at J A transpose, right? So at J A transpose is the transpose of at J. Transpose of at J. That is directly we can write at J A transpose is equal to transpose of at J, that is minus 11, 4, minus 3, 1, 4, minus 3, 7, minus 8, 3. That is interchanging the rows and columns. That is transpose of at J. Okay, that's all. Let A is equal to matrix 1, 4, 0, minus 1, 2, 2, 0, 0, 2. If A inverse is equal to 1 by 12, matrix 4, minus 8, 8, 2, 2, minus 2, 0, 0, 6. Then what is A transpose inverse? That means inverse of A transpose. See here we have the property A transpose inverse. Inverse of A transpose is equal to transpose of A inverse. Okay. So here we need to find inverse of A transpose, right? So inverse of A transpose is nothing but transpose of A inverse. Just find the transpose of this matrix. That is A transpose inverse is equal to its transpose 1 by 12 into 4, 2, 0, minus 8, 2, 0, 8, minus 2, 6. So it is the answer. See, if you don't know the property, you will find its transpose, then you will find the A inverse. It takes time, right? So therefore, if you see, that's why I am saying you should know the properties. So that is the property A transpose is equal to, A transpose inverse is equal to A inverse transpose. Okay? Inverse of A transpose is equal to transpose of A inverse. if D is the determinant of a square matrix A of order n, matrix A of order n, then the determinant of its adjoint is dash. That is, we know determinant of adj A, that is equal to determinant A raised to n minus 1. Right? N is the order of the matrix A. So here D is the determinant A. So we need to find determinant of its adjoint. Right? So determinant of adjoint, that is determinant of adjoint. So adjoint of A at J is equal to D raised to n minus 1. Here it is given that square matrix of order n, therefore D raised to n minus 1. Okay, so D raised to n minus 1 is the answer. If A is a non-singular matrix and A square is equal to I, thus A inverse is dash. It is given A square is equal to I is an identity matrix. If A square is equal to I, if A square is an identity matrix, then A is also an identity matrix, right? So what is the inverse of an identity matrix? See, inverse of an identity matrix is an identity matrix itself, okay? Therefore, A inverse is an identity matrix. If B is non-singular matrix and A is a matrix such that B inverse AB exists, then determinant of B inverse AB is dash. Here we know that determinant B inverse AB, that can be written as determinant B inverse into determinant AB. Right? Here determinant B inverse into determinant A into determinant B. Right? And here, see, determinant B inverse into determinant B. Determinant B inverse into determinant B, that is nothing but an identity matrix. Sorry, B inverse, that is an identity matrix. Right? So its determinant is nothing but, that is determinant of an identity matrix is 1. Okay? That is B inverse or B inverse B, that is equal to an identity matrix. Okay. So what is its determinant? Determinant value is 1. Determinant of I, that is equal to 1. Okay. So here it is nothing but, this can be written as determinant B into determinant B inverse, that is equal to 1. Okay. So here determinant B inverse into determinant B is 1, and so it is equal to determinant A into 1, that is determinant A. So the answer is determinant A, or you can write determinant of A. Okay.